All right, welcome to the first lesson here in Unit 1-2, One Variable Statistics. We're looking at an introduction to data and graphing data. And what I would like you to be able to understand or know by the end of this lesson is we want you to be able to understand the different types of data, what is data, and how to sort of classify it into different types. So specifically the difference between quantitative and qualitative data and discrete and continuous data. And we're also going to sort of introduce you to the difference between one variable analysis and two variable analysis. The topic of this unit is one variable statistics. So what exactly does one variable mean in the context of statistics? And then in the second part, we're going to take a look at some types of graphing here. You've done a lot of graphing before, but we're going to look at one type of graph that you're going to be using a lot and that you might not have done before, and that is a histogram. So you're going to be able to create a frequency distribution in a histogram for a data set. You can do this using technology or using paper and pencil. And we want you to understand the main difference between the histogram that you're learning to do and a bar graph, which you've likely done before. So, what is data? It's hard to define exactly what data is. We could call it a collection of facts from which conclusions can be drawn. It can be measurements, it can be counts, it can be descriptions. It's all kind of this big nebulous thing, but we're going to be concerned a lot with data which can be expressed in terms of numbers, because data in this case is what we might call the raw material of statistics. Statistics, you can see down at the bottom, is a type of information obtained through mathematical operations on numerical data. And what do we mean by information? Well, information is data which has been recorded, classified, organized, related, or interpreted within a framework so that meaning emerges. So we start with data, which in many cases is just a big collection of numbers. We are going to do some statistical analysis on it to extract information from it, and this information is going to be in the form of a conclusion or an interesting observation or something like that. So to put it sort of very succinctly, there's that statement in red in the middle. Data has a story to tell. Our job in the course is to take that data and figure out what that story is and communicate that story to other people. So, types of data. Quantitative versus qualitative. And as we talk about data, we are going to use this term variable a lot. So variable is just some attribute of something that can be, again, measured, counted, described, whatever. All of those things that we talked about in terms of data apply equally well to a variable. And as long as it's something that can change about that object or thing that we are investigating, we can call it a variable. So we can talk about quantitative variables. Quantitative variables are variables that can take on numeric values. So for example here, we could have a variable that is this class's midterm grades. Those are obviously going to be numbers like 50% or 90% or what have you. And because we can express those in terms of numbers, I hope it's not 50%, 90% would be much better. Because they can be expressed in numbers, that would be a quantitative variable. If, on the other hand, we were to look at something like the class's favorite colors, which would be things like red or blue, those can only be described in terms of words. So we would call that a qualitative variable. So qualitative variables are often sometimes called categorical because we can divide these things into categories. All right. Now, quantitative data can in turn be divided into two types. We can have discrete data, and that's data which can only take on very specific values, or there are sort of gaps between the values that this variable can take on. Okay, so things such as things that can only be represented by integers or by whole numbers are discrete data, because if something can only be represented, can only have the value 1, 2, 3, 4, 5, and not 1.5 or 2 3/4, that would be discrete. There's a gap between those integer numbers. And often things that are counted, or variables that represent things that have been counted, are discrete data, because you either have 3 of something or you have 4 of something. You don't usually have 3.5. On the other hand, continuous data is data that can take on any value over the range of that data. There are no gaps between the possible values here. So anything that can be represented by the set of real numbers is considered to be continuous. Things that are measured are often continuous, or almost always continuous. Because if you're measuring somebody's height, let's say you can have 35, like 180 centimeters, you could have 190 centimeters, you could have 180.5, you could have decimals, fractions, that sort of thing. Okay, so that would be continuous data. So just to sort of hammer that home, here we have 5 variables listed. We want to classify the type of data for each one of these variables. So the first one here is the length of an animal. It doesn't say what kind of animal it is, but if we're measuring the length of it, that value is going to be a number. So this is definitely quantitative. And if it's something that we're measuring, it's probably going to be continuous. Okay, because this animal could have a length of like 5.27 meters, let's say. Okay, we could have any decimal there that we wanted. All right, shirt size, small, medium, large, extra large. We're describing those in terms of words, so those are qualitative. Basically, if it's not numbers, it's qualitative. Now, the shirt size is a little bit of a strange one, because if we measure it small, medium, large, extra large, it's definitely qualitative. But if we had given a list of shirt sizes as being, size 10, size 12, size 14, in that case, we would say that the data was quantitative and discrete. Because although there might be a size 11 in between the 10 and the 12, there probably isn't a 10.5 or a 10 and 3/4. Okay, so sometimes it depends on how that variable is defined or how the data is actually collected that determines what type it is. All right, number of children is definitely quantitative. And of course, it is also going to be discrete. We can have 3 children, we can have 2 children, we can't really have 2.5 children, that's kind of messy. And although sometimes you will see numbers like the average number of children in a Canadian household is 2.5, it doesn't mean that there are actually 2.5 kids in that household. And it's not referring to the value of a variable, it's referring to a statistic derived from a set of data. So the statistic average number can take on any value that it wants, even if the variable itself is discrete. All right, color of jelly beans, this would be obviously qualitative. Amount of sand, well, this is definitely going to be quantitative. Now, when we get to whether this is continuous or discrete, this can poses us with a little bit of problem. If we measure the amount of sand, let's say we measure it by mass, let's say we say that there's 10 kilograms of sand sitting in a pile on the floor, then that would be continuous, because we could have 10.0, we could have 10.7, we could have 10.9, we could have any sort of value that we wanted. But what if we, on the other hand, instead of measuring sort of the volume of it or the mass of it, we count the number of grains? Well, then it would be discrete. We could say that we have 1,000 grains of sand. So sand is divided into individual grains. You could say that you could always count the individual grains and it would be a discrete variable. But in most respects, because the number of grains of sand is so large, we're going to treat it as a continuous variable. So there is sometimes a little bit of confusion, sort of maybe a gray area, whether something is discrete or continuous. All right. The difference between one variable statistics and two variable statistics is, well, it's right there in the names actually. One variable statistics only uses data from one of the variables in our data set. Our data set may only consist of one variable, but we're only calculate a one variable statistic using data from one variable. Whereas if we're doing two variable statistics, we use data from two different variables in our data set. So we've got a data set here, which is some standings from a hockey league. And in this, there are 7 variables. Okay, we've got the team name here, which is a qualitative variable, something that can change. And then we've got the other 6 over here, wins, losses, ties, goals for, goal gains, and points, which are all quantitative variable. We'll say that there's 6 quantitative, and we'll say that there is 1 qualitative variable. So we can do some analysis or some statistics on this data set. One thing we could make is a bar graph. We could take the team names and the number of points, and we could make a graph here where we plot the team name across the bottom and the number of points they have up at the top, and make ourselves a nice little bar graph. This, of course, is two-dimensional or two-variable analysis. Okay, because we're using 2 of those variables, team name and points. We could, on the other hand, calculate the average number of points. Okay, you can see we just add them all up, divide by the number of teams, which is 6. This would be one variable, or 1D, because we're only using that one variable, the number of points. Okay. So, just to recap, data has a story to tell. Our job in this course is to figure out what the story is and tell that story to others. And graphing data helps us to do both of those things. So that's what we're going to look at next, is graphing data.